Hey folks, welcome to my channel Number Pen. Hey folks, welcome to my channel Number Pen. We have another interesting problem in front of us. Let r and s be integers, then 6 to the power r plus s into 12 to the power r minus s is divided by 8 to the power r into 9 to the power r plus 2s is an integer if it's a multiple choice question. If r plus s less than or equal to 0, or s less than or equal to 0, or r less than or equal to 0, or r greater than s. So this is a question that appeared in Oxford mathematics admission test, and I thought this will be a good problem to discuss in our videos. This will be a good problem to discuss in our channel. So I've written the expression out here, and we notice that 6, 12, 8, 9 are all integers, and we've been asked to find this whole number, right, which is 6 to the power r plus 2s into 12 to the power r minus s divided by 8 to the power r into 9 to the power r plus 2s. When does that become an integer? That's what we've been asked to find. So let's rewrite this equation. 6, 12, 8, and 9 are integers, so we can, and we've been asked to find if this particular expression what we see on our screen, on under what conditions it becomes an integer, and we've been asked to pick one of the four answers, right? So the way I approach this problem is 6, 12, 8, and 9 are all can be written in the form of 2's and 3's, right? Because all of them have 2 and 3 as their factor. They either have 2 and 3, or they have 2 or 3, right? So let me write this as 6 as 2 into 3. And what do I get? 2 to the power r plus s into 3 to the power r plus s, right? So similarly, 12 is 2 into 3 into 2, right? So I have 2 to the power r minus s. And again, I write it as 2 to the power r minus s into 3 to the power r minus s, right? So I'm going to quickly take you through what we have done in the numerator before I go to the denominator. So 6 is 2 into 3. So 6 to the power r plus s is rewritten as 2 to the power r plus s into 3 to the power r plus s. And similarly, 12 is 2 into 2 into 3, right? So 2 to the power r minus, so 12 to the power r minus s becomes 2 to the power r minus s into 2 to the power r minus s into 3 to the power r minus s, right? So let's quickly do the denominator as well. So I have 8 to the power r, which I write it in a very similar fashion. What is 8? It is 2 to the power 3, right? So I write it as 2 to the power r into 2 to the power r into 2 to the power r, right? And similarly, I have my 9 to the power r plus 2s. 9 is 3 square, right? So it's 3 into 3. So I rewrite this expression again as 3 to the power r plus 2s into into again I write 3 to the power r plus 2s, right? So now we have an opportunity to rewrite this further, right? We have expressed everything as either 2 to the power something or 2 to the power something into 3 to the power something, right? So let's combine all the 2's and the 3's uh, in the numerator and the denominator. So we have got 2 to the power r plus s and 2 to the power r minus s into 2 to the power r minus s, right? So we know that 2 to the power a into 2 to the power b is nothing but 2 to the power a plus b. So which leaves me with 2 to the power r plus s plus r minus s plus r minus s, which means that I'm left with 2 to the power r written 3 times 3r, and you have s minus s, which is s minus 2s, which is s minus s, right, which becomes minus s, right? And I'm going to write my 3 as well. Similarly, I'm going to write my 3. So 3 is nothing but 3 to the power r plus s into 3 to the power r minus s, right? And I apply the same formula, 3 to the power a into 3 to the power b equals 3 to the power a plus b, right? So I get r plus s plus r minus s. My r minus s, my s gets cancelled, so I'm left with 3 to the power 2r. So that's it with my numerator. Let's go to the denominator and see what we have. We have in our denominator, we have got 2 to the power r written 3 times. So that makes it 2 to the power 2 to the power 3r, right? And then we have 3 to the power r plus s into 3 to the power 3 to the power r plus 2s into 3 to the power r plus 2s, right? I can rewrite this as 3 to the power 2r plus 4s, right? So now let me draw the divide symbol. So let's review this once again. So I have 2 to the power rs into 2 to the power r minus s into 2 to the power r minus s, right? And all that I'm doing is using the formula 2 to the power a into 2 to the power b is equals to 2 to the power a plus b, which makes it 3r minus s for the 2 part of the numerator. And for the 3 part of the numerator, applying the same formula, we have 3 to the power r plus s into 3 to the power r minus s. The s gets cancelled and we are left with 3 to the power 2r in the denominator. And applying the same formula for the denominator, we have 2 to the power r written multiplied 3 times becomes 2 to the power 3r, and we rewrite 3 to the power r plus 2s into 3 to the power r plus 2s as 3 to the power 2r plus 4s, right? So now we see that we are left with an expression which has got, you know, just a 2 and a 3 in the numerator and the denominator, and looks like we can further simplify it, right? So we rewrite, I'm going to write it here, 2 to the power 3r minus s. Now I use the formula 2 to the power a minus b is nothing but 2 to the power a divided by 2 to the power b. So I can write my 2 to the power 3r minus s as 2 to the power 3r, and I'm going to copy this, folks, into 3 to the power 2r, and my 2 to the power minus s goes to the denominator, right? And I'm going to write this 2 to the power 3r as it is into the part of the numerator which we'll have to bring it to the denominator, right? Because 2 to the power 3r minus s is nothing but 2 to the power 3r divided by 2 to the power s. So let's write that. And then 3 to the power 2r plus 3 to the plus 4s, we rewrite that in a much simpler fashion so that we can cancel out the 3 to the power 2r expression into 3 to the power 4s, right? I hope you folks are with me. All that I've done is 3 to the power 2r plus 4s is rewritten as 3 to the power 2s into 3 to the power 4s. And 2 to the power 3r minus s, which is this numerator expression, right? Let me see if I can highlight it. Yeah, this expression rewritten as 2 to the power 3r, which is retained in the numerator, and 2 to the power s comes out to the denominator, right? Now we have an opportunity to cancel out a few of the items, right? So I can cancel out 2 to the power 3r. I can cancel out this. I can cancel out my 3 to the power 2r as well, right? That leaves us with an expression that's got only s, right? You rewrite it. So 2 to the power, so we have 1 divided by 2 to the power s into 3 to the power 4s, both 2 to the power s and 3 to the power 4s in the denominator, right? So I'm going to bring it up. That makes it 2 to the power minus of s into 3 to the power 3 to the power minus of 4s, right? This is the final expression. And for this expression to be an integer, right, let's imagine if s is going to be greater than 0, then we have this expression going to be lesser than 1, right? Let's assume if s is equal to 0, then we have this expression as 2 to the power 0 into 3 to the power 0. Let's assume is s is negative, right? Then we have 2 to the power minus s is still an integer, and 3 to the power minus 4s will be a positive integer, right? Will be an integer, right? This expression always remains positive because an integer to the power of any integer, we've been given that r and s are integers, so it remains positive throughout. So I'm just going to repeat it. So if s is lesser than 0, then 2 to the power minus s becomes an integer, right? Let's assume s equals minus 2, then we have 2 to the power minus s becomes 4, which is 2 square. And similarly is the case with 3 to the power minus 4s, right? And if s is going to be positive, then we have 2 to the power minus 2 become 1 by 4. uh, then it becomes a expression which is lesser than 1, and it's no longer an integer, right? And when s is equal to 0, we have this expression as 2 to the power 0 into 3 to the power 0, which is equal to 1, which means that it is still an integer when s equals 0. It's an integer when s greater than 0, and it's not an integer when s is lesser than 0. So I think we have s is lesser than 0 as our final answer. Thank you. So I hope you found this video useful. Please do subscribe to my channel Number Pen. Have a good day. Thank you.